Hello students, welcome to Physical Science online classes. Today we are going to learn about common salt, chemicals from common salt, sodium hydroxide from common salts, baking soda, bleaching powder, washing soda and plaster of Paris and their uses. Common salt, a raw material for chemicals. Salts are the ionic compounds which are produced by the neutralization of acid with base, and salts are electrically neutral. There are number of salts, but sodium chloride is the most common salt among them. Sodium chloride is also known as table salt or common salt. Sodium chloride is used to enhance the taste of food. Seawater contains many salts dissolved in it. Sodium chloride is the predominant component and it is separated from these salts. Deposits of solid salt are also found in several parts of the world. These deposits of large crystals are often brown due to impurities. This is called rock salt. Beds of rock salt were formed when seas of bygone ages dried up. Rock salt is mined like coal. The common salt is an important raw material for various materials of daily use, such as sodium hydroxide, baking soda, washing soda, bleaching powder and many more. Let us see how one substance is used for making all these different substances. Sodium hydroxide from common salt. Sodium hydroxide formula NaOH, that is also called caustic soda. When electricity is passed through an aqueous solution of sodium chloride, sodium chloride is also called brine solution. When electricity passes through the brine, it decomposes to form sodium hydroxide. This process is called chloroalkali process. Chloroalkali process. Because of the products formed, chloro for chlorine and alkali for sodium hydroxide. See the picture. Yes. Sodium chloride plus water gives rise to sodium hydroxide plus chlorine plus H2. Chlorine gas is given off at the anode and hydrogen gas at the cathode. Sodium hydroxide solution is formed near the cathode and three products produced in this process are all very useful. See the picture. At cathode, hydrogen gas. At anode, chlorine gas is released. Hydrogen is used in fuels, margarine, ammonia for fertilizers. And chlorine gas is used for water treatment, swimming pools, PVC, disinfectants and chlorofluorocarbons, CFCs and pesticides. Hydrogen gas and chlorine gas is useful for hydrochloric acid making, for cleaning steel, ammonium chloride, medicines and cosmetics. At cathode we see already sodium hydroxide, which is our important chemical. It used in degreasing metals, soaps and detergents, paper making and artificial fibers. If you combine chlorine gas with sodium hydroxide, it forms bleach for household bleaches, calcium oxychloride, and bleaching fabrics. In this way, these are very useful. Now, we go for bleaching powder. You know that already chlorine is produced during the electrolysis of aqueous sodium chloride, which is called brine. This chlorine gas is used for manufacturing of bleaching powder. Bleaching powder is produced by the action of chlorine on dry slaked lime. Slaked lime is calcium hydroxide, CaOH taken twice. Bleaching powder is represented by the formula of CaOCl2, calcium oxychloride. Though the actual composition is quite complex. See the chemical equation. CaOH taken twice plus chlorine gas gives rise to CaOCl2, which is called bleaching powder, plus water. Uses of this bleaching powder. Bleaching powder is used for bleaching in cotton and linen in the textile industry, for bleaching wood pulp in paper industry, and for bleaching washed clothes in laundry also. It is used as an oxidizing agent in many chemical industries. Oxidizing agent in many chemical industries. Bleaching powder also used for disinfecting the drinking water to make it free of germs. And also it is used as a reagent in the preparation of chloroform. In the preparation of chloroform also we used bleaching powder as a reagent. Next we go for another chemical which is from common salt is baking soda. Baking soda, chemically it is called as sodium hydrogen carbonate. NaHCO3 is the formula. Baking soda is sometimes added for faster cooking. The chemical name of the compound is sodium hydrogen carbonate, NaHCO3. It is prepared as sodium chloride plus H2O water plus carbon dioxide plus ammonia gives rise to NH4Cl, ammonium chloride, plus the baking soda, NaHCO3. If you find the pH of sodium hydrogen carbonate as earlier in the activity, you predict the reason for using NaHCO3 to neutralize an acid. Can you predict it? Yes, NaHCO3 is basic in nature. So baking soda is a mild non-corrosive base. The following reaction takes place when it is heated during cooking. What happens while cooking? NaHCO3, sodium hydrogen carbonate, on heating gives off sodium carbonate, water and carbon dioxide. That's why we use in the following way. Uses of sodium hydrogen carbonate, baking soda. We know baking powder is a mixture of baking soda and a mild edible acid such as a tartaric acid. When baking powder is heated or mixed in water, the following reaction can take place. NaHCO3 plus H plus gives rise to carbon dioxide plus H2O plus sodium salt of an acid. Carbon dioxide produces during the reaction causes bread or cake to rise, making them soft and spongy, smooth and spongy. That's why we use this baking soda in cooking. Another use is sodium hydrogen carbonate, baking soda, is also an ingredient in antacids. We already know about antacids. Antacids are used for neutralizing excess acids. Being an alkaline, it neutralizes excess acids in the stomach and provides relief from the stomach pain. And the next one is, it is also used as soda acid in fire extinguishers. Why in fire extinguishers? Because on heating it releases carbon dioxide gas, which is used as a fire extinguisher. And it acts as mild antiseptic also. It is also one of the most useful. It acts as mild antiseptic. This is all about baking soda. And now we go for the next chemical, that is washing soda, sodium carbonate. Another chemical that can be obtained from sodium chloride is sodium carbonate 10H2O, which is called washing soda. You already have seen about the sodium carbonate can be obtained by heating baking soda. On heating baking soda, we can get sodium carbonate. Recrystallization of sodium carbonate gives washing soda. It is also a basic salt. Washing soda is a basic salt. See the equation. Sodium carbonate plus 10H2O gives Na2CO3 10H2O. Sodium carbonate and sodium hydrogen carbonate are useful chemicals for many industrial processes. See here uses of this washing soda. Washing soda or sodium carbonate is used in glass, soap and paper industries. Glass industry, soap industry and paper industry. It is used in manufacturing of sodium compounds such as borax. Washing soda is used in the manufacturing of sodium compounds such as borax. And sodium carbonate is used as a cleaning agent for domestic purpose. In our houses, we use sodium carbonate as a cleaning agent. Usually, we use washing soda in washing of clothes. And it used for removing permanent hardness of water. It is used for removing permanent hardness of water. Here, one thing is there. What does the 10H2O signify? H2O means, does it make sodium carbonate wet? Are the crystals of salt really dry? Let us see removing water of crystallization. Actually, to demonstrate this, we need to do one activity. See here, take a few crystals of copper sulfate in a dry test tube and heat in the test tube. You will notice that water droplets are formed on side of the test tube. Add 2 to 3 drops of water on the sample of copper sulfate obtained after heating, which is changed its color from blue to white. After adding 2 to 3 drops of water, blue color of copper sulfate is restored. In this activity, copper sulfate crystals, which seems to be dry, contain the water of crystallization. When these crystals are heated, water present in crystals is evaporated and the salt turns white. When the crystals are moistened with water, the blue color reappears. Here, these are called water of crystallization. Water of crystallization is the fixed number of water molecules present in one formula unit of a salt. 5 water molecules are present in one formula unit of copper sulfate. The chemical formula of hydrated copper sulfate is CuSO4 5H2O. And in previously we have seen in washing soda there are 10 water molecules are present in washing soda. So now you would be able to answer the question whether the molecule of sodium carbonate 10H2O is wet or not. Is it wet or not? Say children. Very good. Another salt which possesses water of crystallization is gypsum. It has two water molecules in its crystal and the formula is calcium sulfate 2H2O. CaSO4.2H2O is called gypsum. There is a question already asked. What does H2O 10H2O signify in sodium carbonate 10H2O? The answer is 10H2O is the water of crystallization. It does not make the molecule sodium carbonate 10H2O wet. Another salt is plaster of Paris. Is called calcium sulfate hemihydrate. Calcium sulfate hemihydrate. How we get this plaster of Paris? How we prepare? On careful heating of the gypsum, earlier said, calcium sulfate 2H2O, CaSO4 2H2O. On careful heating of this gypsum at 373 Kelvin, it loses water molecules partially to become calcium sulfate hemihydrate, CaSO4 half H2O. This is called plaster of Paris, the substance which doctors use as plaster for supporting fractured bones. In the right position, the plaster of Paris is a white powder and on mixing with water, it sets into hard solid mass due to the formation of gypsum. See the reaction: calcium sulfate half H2O plus 1.5 H2O gives rise to calcium sulfate 2H2O. Uses are already see the uses. This is called plaster of Paris. This plaster of Paris used doctors as plaster for supporting fractured bones in the right position, and it is also used for making toys, materials for decoration and for making surfaces smooth. Children, now take the homework. Name the chemicals which are prepared from the common salt. 2. Write the uses of sodium hydroxide. 3. Write the preparation process and uses of bleaching powder. 4. What is baking powder? How does it make the cake soft and spongy? Number 5. Give 2 important uses for each of washing soda and baking soda. 6. A milkman adds a very small amount of baking soda to fresh milk. A. Why does he shift the pH of fresh milk from 6 to slightly alkaline? B. Why does the milk take a long time to set as curd? 7. Plaster of Paris should be stored in moisture-proof container. Explain why. Write the preparation process and uses of plaster of Paris. Final question. Write about water of crystallization with 2 examples.